So hey guys, we are back again with one more numerical based on the time response analysis of control system. So here they have given the question as for a unity feedback system basic. What is unity feedback? Feedback will be unity. That means feedback will be 1. That means what is given? Given data is nothing but h of s is equal to 1. Simple. Next, g of s value they have given it as 36. I'll just write it over here. Okay, 36 by s into s plus 0.72. Okay, so this is the given g of s value. Now here we have to determine the characteristic equation. Now this is the new thing we are going to study, characteristic equation, and hence find the damping ratio, peak time, settling time, peak overshoot, number of cycles completed before output settles for a unit step input. This also is a new concept we will be studying. Okay, so everything will be covered in this only. So we'll discuss first thing, we have to determine the characteristic equation. What is characteristic equation? Whenever you write the transfer function, it will be closed loop transfer function. It will be in the form of g of s by 1 plus or minus g of s into h of s. Now this denominator is nothing but what? Denominator of the transfer function is called as what? Characteristic equation. So always remember, it is the denominator of transfer function. You can write closed loop transfer function. Okay, closed loop transfer function of a system. Okay, close to transfer denominator close to transfer function is nothing but the characteristic equation. Equation means always you have to put equal to sign. So equal to, you will write it as what? Equal to 0. So equate this denominator to 0. Characteristic equation. So let me just write. So that is given by, characteristic equation is nothing but 1 plus g of s into h of s, which is equal to 0. Always equal to 0 because this is the equation. Okay, so always equal to sign will come. Now here, what is g of s? G of s they have already given in the question. What is h of s? They have already given in the question, which is unity feedback. That means it should be 1. Now can I write the characteristic equation? Therefore the characteristic equation will be is 1 plus g of s into h of s equal to 0. That means it is 1 plus g of s value is 36 by s into s plus 0.72, okay, into h of s is 1 equal to 0. I hope you understood. So characteristic equation. Now can we simplify this one? Yes, you can simplify. Just to take LCM. So here 1 is the denominator 1. Then you have to multiply this thing so that denominator will be same. So that implies the characteristic equation denominator will be s into s plus 0.72. Okay. And the numerator will be s into s plus 0.72 plus 36. 1 into 36 is 36. Okay, equal to 0. Now can I just take this to that side? So it will be 0 into this thing, so it will become 0. So what is left out? S into s plus 0.72 plus 36 equal to 0. Now this I can simplify again. What, open the bracket, s into s is s square, then 0.72 s plus 36 equal to 0. So this is my characteristic equation. So first part of the question is done. Now from this, can I get the value of peak time damping ratio? Because in previous questions we have found out the close to transfer function, this entire thing, right? This entire thing we found out. Then we went for what? Comparison with the second order system standard equation, which is nothing but, so let me just write it. So in previous type of questions we compared the standard equation of second order system. Standard equation, let me just write. So standard equation of second order system. That second order system standard equation is nothing but omega n square by s square plus 2 zeta omega ns plus omega n square. Now always remember, this is equal to what? This is equal to the transfer function of the second order system, which is equal to c of s by r of s. Simple logic. Okay, this is nothing but this transfer function, right, for the second order. Now here also, this is also a transfer function. We found out characteristic equation. What is characteristic equation? We know that characteristic equation is nothing but, as I said, it is the denominator of the transfer function. So So it will be C of s by R of s, which is equal to the transfer function. So in that transfer function, whatever the denominator is there, okay, whatever the denominator is there, that you have to equate it to 0. That is nothing but the Cartesius equation. Now here also, if you observe, this part is the denominator of the transfer function. This is also transfer function. This is also transfer function. So denominator of the transfer function will be same as the transfer function of this thing. So we can compare directly. No need to find again the C of s by R of s. No need to find again the closed loop transfer function. This entire thing, because we have got this part which is the denominator. Just compare it. This is what we got. This you have to compare it with the denominator of this second order transfer function. Okay. So I hope you understood. So let us proceed. So what we have got here, comparing s square plus 0.72 s plus 36 equal to 0 with the standard equation of second order system, which is s square plus 2 zeta omega ns plus omega n square. Okay. Now only this part you have to compare. Okay, leave this 0 part because it was transfer function, Cartesian equation. Now s square no need to compare because the coefficient is 1. Now can we compare first part omega n square value? Now what is omega n square value compared with? It should be compared with 36. From this can I get omega n value? Omega n value will be square root of 36. Okay, square will go that side. So it will be square root of 36 is nothing but 6. Okay, so we got natural frequency, that is omega n. What is the unit? Radian per second, always remember. Then second comparison will do, which is nothing but 2 zeta omega n, middle term 2 zeta omega ns. Compare it with what? 0.72 s. In this s and s cancel. Now omega n value we already know, which is 6. You can just substitute. So this becomes 2 zeta into omega n value is 6 equal to 0.72. So from this I can get zeta value, which is equal to 2 6 are 12. So 0.72 divided by 12. So can you get the value of that? It will be 0.06 zeta value, which is the damping ratio. Okay. Now after getting this, what I can do? Zeta also you got, omega n also you got. Can we find out the peak time, settling time? Yes, you can find out after getting omega n and zeta. Yes. So it will be, first we'll go for peak time. So first part, which is nothing but peak time, we have to find peak time, which is TP. The formula is pi by omega d. Now the thing is that you need to find omega d. Pi value anyways we know. What is omega d? Which is nothing but the damped frequency. So we have to find, we have the formula for omega d, which is equal to omega n into square root of 1 minus zeta square. So can we substitute the value? Omega n value we know, it is equal to what? 6. We just got it. So 6 into 1 minus zeta square, which is 0.06. This also value we got. So when you substitute in the this in the calculator, you'll be getting as 5.9891 radian per second, same unit as omega n. Omega d we got. Now can we substitute this value and get the answer? So TP is equal to pi by omega d, so which is equal to pi by omega d value is 5.9891. When you substitute in the calculator, you'll be getting as TP as 0.5245 seconds. Okay, unit is very important. Okay, so TP is done. Let us go for settling time also. They have asked settling time. Settling time formula is, notation is TS, and the formula is given by 4 by zeta omega n. Now 4 we already know, it is 4 only. And zeta value is 0.06 into omega n value is 6. So after simplifying, you will get it as 11.11 seconds. That is also done. Let us go for the third part, which is nothing but peak overshoot. Peak overshoot. Notation is MP, right? That is given by, so peak overshoot percentage MP, that is given by e power minus pi zeta divided by square root of 1 minus zeta square. that values we have to substitute, that is equal to e power minus pi as it is. What is zeta value? Zeta value is nothing but 0.06 whole divided by square root of 1 minus zeta square, that is 0.06 square. So you will get it into 100. Okay, one more, it's in percentage into 100. So that is given as, you will get it as percentage 82.79%. Okay, just put it in the calculator. Okay, next fourth part, what we have to find now, we have to find, so everything is done. Now left with, we are left with find, we have to find the number of cycles. Peak overshoot is done. We have to find now the number of cycles and completed before output settles for the unit step. Number of cycles we have to find, right? Number of cycles. So how to find number of cycles? The simple thing here we have is nothing but we have to find the damped frequency. Okay, so thing is that here omega d value we already have, which is nothing but 5.9891 radian per second. Okay, this value we got it, right? Now omega d value is same as 2 pi into fd. Yeah, 2 pi into fd or 2 pi f, we call it as omega is equal to 2 pi f, same thing. Omega d is equal to 2 pi fd. Fd is nothing but the number of cycles per second. Okay, so from this can I get fd value? Fd value will be equal to what? Omega d by 2 pi, right? So omega d value we already have, that is 5.9891 divided by 2 pi. If you do, you will get fd value, which is 0.9531 cycles per second. So in 1 second this much cycle is there. Okay, now what will be time for 1 cycle? That is nothing but given by td. Okay, so td value is nothing but reciprocal of frequency is the time period. So 1 by fd if I do, I'll get time period, which is equal to 1 by 0.9531, so which is equal to 1.049491, okay, seconds per cycle. This much time period is there. Now we have to find the output, that means before the settling we have to find number of cycles before it gets settled down, right? Output settles before output settles. Now here the concept is nothing but we found out td, which is nothing but the time period. Okay, that time period is for one cycle per cycle, right? So one cycle 1.0491 seconds. Okay, now we are having here the settling time, for settling time, right? So settling time we got it as how much? Ts is equal to how much we got it as 11.11 seconds, right? 11.11 seconds. So it will be 11.11 seconds. So for 11.11 seconds, so how much cycles it will be required? This is the question. See, one cycle it is taking this much time. So for 11.11 seconds, how much time it will take? But just to divide this thing, right? So it will be 11.11 divided by 1.0491, which is the answer will give it as 10.59. So this is nothing but number of cycles. So we had to find td first. Okay, for that we found out fd using omega d. Then one cycle we know this much. Then for settling time they have asked before settling time, so that's why we found out this thing. Okay, so this will be the number of cycles.